Hi, my name is Camille Wilson. I'm a PhD student at the Virginia Institute of Marine Science, and today I'm going to be talking about my Virginia Sea lesson plan, which focuses on seagrass restoration best practices, which is also something that I focus on at VIMS for my research. And with this lesson plan, you'll get a presentation that has some background information that's important for the students before they complete the in-class activity. And that includes things like seagrass and its critical ecosystem services, as well as its decline over the last century, and why restoration efforts have become so critical. And also the fact that with restoration efforts, we have to decide where the best places to plant them are, considering the environmental tolerances of the seagrass species of interest that we're working with. And this is something that the students will also consider in the in-class activity, where they'll be given 6 different sites with the handouts, and then they'll be responsible for measuring salinity, temperature, depth, and light availability, and then compiling all of that into a table where they can compare all of the sites together and then figure out how they want to allocate their limited seed resources for restoration. And once they've done all this, they'll have to justify these choices in some of the questions on the worksheet, as well as think about the most important environmental conditions for seagrass restoration and some other factors that might be important that we didn't talk about. So using some of that broader knowledge that you guys are talking about already in your classes. And I really hope that the students enjoy this activity and hopefully it inspires some interest in marine science as well as seagrass restoration. And I'm happy to answer any questions in case they come up during the preparation for this activity.
This is an example of one of the site handouts that the students will be getting measurements from, and it has a refractometer image where they'll measure this blue line to get salinity values, a thermometer image where they'll measure that red rectangle to get temperature values, and then they will get depth values by using the centimeter side of a ruler and measuring from the top of the blue box down to the top of this sandy colored rectangle. And then they will estimate light availability based on how far down the most visible Secchi disk goes. So since this reaches the bottom, it will be considered high light availability. And this will all be included in the Secchi disk key within the handouts. And you can adjust the difficulty by keeping these temperature and salinity values here, or you can delete it on the PowerPoint so that they'll be responsible for doing this on their own.